said a while ago, so there are numeric forms in hemiacetal and hemiketals. So when we talk about alpha form, so sa tuwa niya, ginanumano lang nato, this is alpha and this is beta. So for your new information, alpha form, when the OH of C1, okay, the OH of this portion is opposite to the OH of this portion. Okay, so for example, your OH here is down, then the report is down, is dili siya alpha. Okay, down and down is the same. So, dili up, and this is down, therefore, we can say that this matter is alpha. So, if the same, so the beta is on the same side, that is beta D glucose. And this one is alpha D glucose. Okay, so an anomeric carbon can be identified as the carbonyl carbon of the aldehydes or the ketones. Or somehow, why can we say that it is an anomeric? It is because this portion is either COH or CO, ketone or aldehyde. So in the open chain form of the sugar, it can also be identified as the carbon bonded to the ring oxygen. So this is the ring oxygen and a hydroxyl group in the cyclic form. Okay, so we are done with this. The Fischer projection, then you have here the Haworth projection. Okay, so the monosaccharides have Haworth structures and the chair conformations. Baliktad na naman. Okay, so here we have aldehydes. Then aldehydes plus the alcohol, you can get the word hemiacetal. So this is aldehydes, RCH3, then COH plus OH, that is alcohol, and this is CH3CH3. Then it yields an backward equation kanimong makuha. So it yields R1, that is CH3. Then you have here the carbon that attached with your oxygen and hydrogen. Then you have also here O or oxygen. Then another R2 or CH3 and hydrogen. And this portion, it is known as the hemiacetal. So ang gi-add mo sa imong aldehyde, alcohol, aldehyde plus alcohol, hemiacetal. And the hemiacetal, when you break down mo siya, the forward formation, you can get acetal. And you can get water. So when you add water and acetal, then you can get hemiacetal. Then the hemiacetal, when you add alcohol, then it will get aldehydes. The same process with your hemiketals, because it is acetal because we're dealing with aldehydes. Hemiketals because we're dealing with ketones. Okay, so I will correct my misconception ganina, katong up down. So, one ko class, kay pagtanaw na ko sa last na slides na to is up, sa to ako alpha up, then beta down. But it turns out that in the book na ako ginagamit way back sa ako undergrad, so when we talk about alpha, if your OH is on the right side, okay, DR, D isomer, then right side, then it must be down in your, correct? It must be down in your pyranose. Okay, so when you draw in your pyranose, always remember that the alpha formation must be down ang iyang of this one. This is alpha down ang imuhang OH. So it must be in the Fischer projection or in the bone formation ang imuhang OH na sa right side. Okay? So D isomer right side, pag-abot sa pyranose, it must be downward. Mora na ako ang na-change na ko ganina. Sorry. Okay? So as you can see, This is the Fisher projection. So the first one, this is your COH, then hydrogen. So the first carbon, the OH, is on the right side. Therefore, we can see that that is the glucose. But in your pyranose, or in the drawing, sa inyong 1, 2, 3, 4, 5, 6, there are 6 cyclic formation. And you have here the oxygen ring band. So after the oxygen ring band, you have carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5, and this one is your 6. Okay, so in carbon 1, always remember that since the OH is on the right side, it must be downward. Okay, so right side, it must be downward. So mga na siya class, alpha, if OH is right, then down ang mga pyranose na portion. Okay, na-putro na ninyo yung mindset? Okay. Pasensya kayo din na nakuha, nabali na po. Okay, so may galit ka rin, pagdanang na po, pag-review, okay. So, right side, downward. RD, right side, downward. So, if the Fisher projection is like this, if your isomer or the epimer is L, so left side. L, left side, L, glucose. So, this is L glucose, and the name must be beta L glucose. So, beta because upward ang iyang OH. Beta if the OH is on the left side and it must be upward. So, no. OH group that is written the right on carbon in a Fisher projection has a downward, right, downward direction in Hayward projection. OH group that is written in the left side or to the left side of the Fisher projection, upward in a Hayward projection. Okay? Always remember that your CH2OH group in the sugar is always above. Muna nga, wala may makita na naa siya A. Muna nga, basihan na to, matawag na to siya o alpha and beta sa itong first na slide. Kung kani siya, yung OH diri is the same, ang OH niya, that is beta. Pero kung opposite gani, OH ni mo ubos, naa ko diri sa taas, opposite man sila, up and down. So, ang anomeric carbon nimo is it's either beta ba siya o alpha. So, mo yung minumduman. So, kaning na first slide. Pero kung dili ninyo siya mahinumduman, so dili up, if you cannot understand or remind, ay, natuon din siya pagkuha, then, kami lang hinumduman ninyo. Alpha, right, ang iyang
Right down.
OH, downward.
Downwards.
Beta, left,
Upward.
upward. So, ang matawag-tanaw, okay, look at the Fisher projection before you can project to Hayward projection. So, if ever imani ang OH, then the OH here must be upward because the OH is left side. Okay, so this one. So, pyranose, then you have urine. So, this is the chair conformation. So, from Hayward, nanapod no? Fisher, Hayward. From Hayward to chair conformation. So, there are 3 drawings sa inyong mamugna out sa inyong first or sa inyong itawag na Fisher projection. From Fisher projection, you can have your Hayward projection from Hayward to this messenger lookalike. Okay? So, this is equatorial. Downward is axial. So, always remember that in writing the equatorial side is, pwede siya ana class, pero ang sakto gid niya is ana. Alam ito mura pa ana. Anay bangko. Okay? So the equatorial is above, axial ang ubos. Kaya kung sa hayward, upward, downward. Here, equatorial, axial, equatorial, axial, equatorial, axial. So as you can see, ring band diri. Ring band diri. It depends upon kung sa pag-drawing mo, okay, for example, kani, yung ring band is not diri. Because ring band, 1, 2, 3, 4. Sama sa kong gingon ganina. So it's up to you. If mag-ring band ka diri, automatically, this is your carbon 1. So, asa man yung numeric carbon. So, kung gusto ko ka diri ka mag-ring band, diri ko ka mag-1, 2, 3, 4, 5. As long as kanang imong oxygen band, ika-6 yun na 0. Okay. So, from pyranose to chair conformation or the Hayward projection to chair conformation. So, as you can see, OH is up. In Fisher projection, isa man siya, left or right? Up man siya. Ang OH niya, nasa left or nasa right?
Nasa right.
Up?
Left.
Left. So to,
Left.
pag alpha, if imuhang OH is right side, downward. Beta, if ang OH
Left ang
left,
upward.
upward. So upward man eh. So in Fisher projection, sa yanahin na to, nadiri ang OH. Okay. So, ring band, OH, then, okay. So, kani class, this is our beta, right? Kay naman siya din. Beta, D, glucopyranose. Why is it pyranose? Because this is pyranose. So, kung 5 kunin ka po, glucopyranose. Pero, pwede na po beta, D, glucose. Because in Fisher projection, this is glucose. Pero kung strict ko, ngayon ko, okay, based on its conformation, write the name of the following drawings. So, magamit mo pyranose and pyranose. Okay? So, glucopyranose, glucopyranose, galactopyranose, depende na sa mga Fisher projection. So OH, as you can see, the OH in your Hayward projection upward. So therefore, this is equatorial. Meaning, upward siya pa, upward pa rin ang formation. So kung outside formation, sa imuhang Hayward ng OH, mukot ang formation sa imuhang chair conformation. Ang imuha lang yun, you will understand first the Fisher projection before you can get the value or the drawings of Hayward and chair conformation. Because if you don't know how to analyze the Fisher projection, then automatically in your Hayward and chair conformation, okay, if ever the chiral carbon is here, then imong ikuha na sa pinakatumoy katong CH2OH, then automatically wrong na imuha chair and Hayward projection. So you must know kung asa si carbon and si OH na below. If it is on the right side, then automatically upward in Hayward projection. Then that is beta in A. If it is in downward, then right OH, that is alpha in Hayward projection. This one, as you can see. Okay, this is our Fisher projection. This is our Fisher projection of fructose. Okay, fructose. Why is it fructose? Because C double band O. C double band O is ketone. So fructose for 1, 2, 3, 4, 5, 6. Sa ganito, kung katuta sa naming, na gamit ang C double bond O. Ito, 6. Isang 6.
So.
Hexose. So, ito hexose but it's have its original name na fructose. Okay, mo naman sa nature na to. So, layo sa iyahang chiral carbon, okay? Asa siya ng chiral carbon? Tanaw na to, nasa 4 or nasa 5. So, as you can see here, with this one, beta, and this one is the alpha, the fructo or fructofuranose. Beta fructofuranose. Ano fructofuranose gani? Because we use furan. Sa ganitong ba, pyranose and
Furanose.
basta sa reward na gani, kung mag-inistrikta ko pangayong ngalan, if I will ask you, write the name of your drawing base sa iyahang ring, cyclic ring. So you will use pyranose and furanose. So if I will ask the simple name, then you will give me the keto and aldo, hexose, heptose, that and like that. Okay. So upward. Upward, so asa itong OH? Upward, left. Okay? So your OH must be on the left side. Okay, this one. Na siya sa left portion. Okay, downward atong OH dire. Right. Okay, ma'am. Lagi siya diri. Ingon, extra lagi diri. Dira kay. Okay, since it is furan, 5 raman siya. 1, 2, 3, 4, 5. Ang ring band niya nasa center. Okay? Ang ring band niya nasa center. Ang pulley, okay, ang iyahang sulfide is CH2OH. Okay? Ibali, the ring band is on the center side, then the OH, the opposite side of the OH is CH2OH. Unlike this one, okay, the ring band is different. Nag-check iyahang position. But here, the ring band, ang iyang ring band niya is in the center. Here, the opposite side of your hydrogen is OH. But here, the opposite side of your OH is CH2OH. The same process. So if it is down, that is alpha. Alpha, D, fructofuranose, because we're using 5 rings only. 5 rings, furan. 6 rings, pyranose. Okay. So yun na no, basta makabalo lang mo ani. If you know the drill about this one. RD, right downward. Kung sa mga itong isbutan, basta nag-right, OH na C. Sa Fisher projection. So, for example, this one, the Fisher projection. Your OH is on the right side. Therefore, down one. OH here is left side, upward. Okay? So, para dili mo maghibog, ang first carbon inyong anawon. Sa ingani nga one. Uniform na lang ta. Okay? Katong last na to, kung may mong tag-D epimers and L epimers, we are looking the chiral carbon. Ang pinakalayo, yung malayong parte niya sa COO, sa COH, C double bond OH and C double bond O. But in here, they are focusing on the first layers ng carbon. So, as you can see, the first layer carbon na siya ay OH in the left side. Boy lang ibasihan to upward. And here is on the right side, downward. Para uniform. So, sa epimers mo, sa D and L, sa chiral carbon. Ano lang kayo mong duman. D and L, use the chiral carbon naming. Here, use the first carbon in naming alpha and beta, upward and downward. Damo na mo inumduman. Okay, mutual rotation. Okay, so as you can see, What I have said, upward, downward, the same rulings. The same rule niya. So, kayo lang ka na itawag ang mutation because the hemiacetal or the alpha or beta D-glucose forms an open chain. Okay, this one, ano yung meaning ng open chain? But because of the hydrolysis power, the breakdown or the analysis nga nabuhat, mo na nga nananayin siya chain para matakdo ni isa ka carbon. So, an open chain muta-rotation. So, in our case, dahil man ang muta-rotation, pag ma-mutate ganin lang ato ang mga cells, lahi man ang may tabo sa tuwang body. So, mo ba na no, nga, dugay kayo nawala ang COVID-19 because of the mutation or mga muta-rotation na itabot niya. Matong matay delta, karon sana po na napoy nipa, sana nipa virus. Kung sana silang mga mananapa. Okay, so carboxylic, we are done with this. Okay, the oxidation, ano sa ganito? Kung i-oxidize ang ulo, aldonic. Okay, oxidize ang tail, uronic. Okay, oxidize ng kondwa.
Aldaric.
Okay, so what are some reagents gani nga gamiton nimo pag oxidize kanin sila?
Tolerance.
Benedict, Barfoot, fillings, and tolerance. So according to Makiti, they are done with filling steps. So if complete na mo next meeting, so pwede ka makakuha na nila na mamit ka sa bado. So these are the redox tests for carbohydrates. The Benedict, then Barfoot, fillings, and tolerance. Dayon magkuha na din ka magsabot din ka kung sa'y trabaho ninyo sa laboratory na isa ninyo sa ako. Tara. Mamigilin na natin. Number 1. Kung i-oxidize mo ang ulo, ang aldehyde extract, nahimo siyang carboxylic acid. Ang tawag niya aldonic acid. Example, oxidize from this, nahimo siyang C-O-OH, gluconic acid. Gluconic acid. Pero ang rin na oxidize, kanilang tawag dito open chain formation, the CH2, uronic yung glucuronic acid. Pag anduhan na lang niya ma-oxidize, ulo o PL, then aric or glucaric acid. So, kung kayo, accord kayo, galactaric acid. Galactose. Reduction. So, mag-reduce. Okay, so, meaning, gikan sa COOH, back to its original equation. Maoragid na si reduction plus. When you talk about reduction, from imo siyang ihilabtan nga mahimog siyang another, then naabot siya isa ka reagents nga imo na siya mabalik sa iyang original formation. Kani mo ay pinaka-common nga reduction process. The laboratory reduction of glucose to form D-glossitol. Okay? D-glossitol or sorbitol. As you can see, glucose, C-O-H. Then, because of the reduction, ang nahitabo niya, CH2OH na siya. Because of the enzymes. Bahok kayo niya siya, guys. Bahok niya siya o kanang, sana, yung physical bitaw niya. So, okay, so, redox reactions, we will use Benedict, Barfoot, Felling's test, and tolerance test. So for the Barfoot, it is more sensitive that it can distinguish a reducing monosaccharide from a reducing disaccharide. Makuha niya, sensitive lang kayo siya, so dali niya ma-distinguish na, okay, this one is from disaccharide. Two sugars ang involved, then makita din niya naman yung colors nga appropriate sa iya. So, kunyari, using Barfoot's test, you can get color green. Automatically, if that is color green, then you can distinguish that this is disaccharide. Divided into pieces form a monosaccharide. Okay, sugars, amino. Okay, so class, kung may gani ka, when you talk about phosphate ester formation, always remember that this one, phosphate, naginite phosphorus. Kung may po kag amino acid, always remember, nagyutay nitrogen na involved ni. Because amino, from the word amino, amine. So, amine, NH2, amino, ammonium hydroxide, NH4OH, ammonia, NH3. Mona, amino acid ang tawag niya. Okay, so glycoside formation. So, kanina, we're getting the glycoside bonding. So, ani ang glycoside bonding. Okay. This one. Alpha and beta 1,4 glycosidic bonds in a disaccharide using chair conformations. So, once nakabalo na ka o Fisher, Hayward, automatically easy na kayo is. Okay? So, this one is atrial and the other dealing na part is equatorial. So, as you can see, alpha, beta, 1,4. So, as what I have said kanina, so, this is your oxygen bond. 1, 2, 3, 4. So, this is your oxygen bond. This is 1. So, the bonding of this, this one, ang naitabo niya is kanin C. So, 1, 2, 3, 4. So, you have 4, 1. Therefore, okay, since kanin siya is beta ang gamit niya, your answer must be beta L-glucose or L. So, payag na ninyo sa name. So, this one, ang iyakas is oxygen bond. 1, 2, 3, 4. Oxygen bond. 1. Dili ka mo, oxygen bond. 1, 2. Okay, kung mayroon ka, dili ka magsugod. So, this is not 4. That is beta alpha. Beta 1, 2. Kung dili ka magsugod, oxygen bond. 1, 2. And dili man yung bonding. Kunya kay dili man siya 1, 2, 3, 4. If this is oxygen bond, automatic 1, 2, 3. Dili ka oxygen bond 1, 2, 3. Misconception na. Okay? So, this one, ang iyang bonding is, ikaw mag-grow. You will be the one to decide. Looks like this ba yung mga pag-grow? Or tapad na mo? As long as kabalo ka where to put the glycosidic bond based on the number that we have said. Now, there is a chance na I will give you the confirmation, but you will be the one to draw kung asa ang iyang glycosidic bond. If I will ask, okay, using the chair conformation of L-glucose or L-maltose or L-galactose, okay, draw or show to me beta 1, 4 or 1, 3 glycosidic bond.
Then, inanano mo.
Ingan niyo na ninyo. Using chair conformation. If I will ask using Hayward projection, looks like this. Dili man tama ka, hatag na ni o glycosidic bonding. Kaya kanila siya ang basehan. Ibalik, kung natay monosaccharide na building block, naputay building block sa itong drawing. See? Fisher projection. Okay? Kaya na ni? Kaya na ni, no? May bawa na ni? Gamay. Okay, alpha 1, 4. Okay, alpha, kung sa ganito, kung mag-alpha ta, magamit ka alpha, kung opposite
Glyco.
ang duha. Opposite sa side, dili na din natin masulot. O, tanawa. Nag-alpha siya, di ba? Ma'am, anong alpha? Why is it alpha? Because this is, okay, bali, this is equatorial axial. Then this one is, equatorial yun o, dayon, axial. Ito ba? So, drawing na ito ganina. Okay, equatorial ang ibabaw, axial ang ubos. Okay. Equatorial sa ibabaw, axial sa ubos. As you can see, kita ninyo, opposite lang formation. Unlike kaniniya, nag-abot na sila, paibabaw na sila. Therefore, what is beta? So, muna ninyo minungguman. Beta, the same position. Or, kung niladaan na beta, why not? Mag-alpha na po sa yung final. Beta rin niya po ba? Kung ano yung nauna, yun nila yung survey. But always remember ha? 1, 2, 3, 4. Dili magmuna si 4. Eh, basin mo kayo mo, ha? Once nag-ihap ko, ma'am, I count the number. Start. 1, 2, 3, 4. Before akong di una, dayon, kung saan na ito nag-1, ay nabuing. Isa may una anin lang 2. 1. So, more na inyo ang bantayan.
Daghan may bantayan.
Dagan kayo magbantayanan sa drawing. Dilita. Because we're talking about disaccharide. So, the first example is maltose. As you can see, the name of the maltose is alpha-D-glucopyranosyl 1,4 or alpha-D-glucopyranose. Why is it glucopyranose? Because before na nakabot siya sa conformation, chair conformation, kani pa yung ibuwa, Hayward projection. That is why they use glucopyranose. Okay? So, alpha-1,4 glycosidic bond. So, kung ato siyang i-Hayward projection, Victoria. Okay, alpha-1,4. So, the same. 1 and 4. Dili ang ilang meeting point. Because O-ring or O-band, ang ilang oxygen band, 1, 2, 3, 4. Oxygen band, 1. Therefore, what will happen? So, this one is oxygen na lang ang mahitabo plus water. Because OH plus OH, it will yield to oxygen bond known as glycosidic bond. So, kung sa ngalan nila, muna alpha-D
Gluco.
because we're using pyranose. We're using katong murag payag, balay, urine.